Okay, so today's video is going to focus a lot on calculator skills that will help you throughout the year. To begin, if you could take a second, pause the video, and put the function here, f of x, into a graphs page. Now, I would suggest when doing that, open a new document so that when you put it into the graphs page, it will go in for f1. So again, take a second, pause the video, and put it into a graphs page. So you should have in F1, you've got 3x cubed minus 5x squared minus 2. And we've got that in a graphs page. What our goal is to evaluate some different values for this function. Now, if you have multiple values you have to evaluate for a given function, this can be a very useful tool. If you just had to do one thing, like our first one there, f of 2, it's probably going to be quicker to just plug in f of 2 and plug it in on a calculator's page. But when we have multiple things, like we're going to have 4 different things that we're going to look at, we can put our function to a graphs page and then add a calculator page. To add a calculator page, the plus page is above the dock button, so we can do Control and then the dock button and add a calculator page. Now, it's important that you don't open a new page, it's got to be, or a new document, it's got to be part of the same document. Well, we put our function that we wanted in F1. So we can just use function notation and do f of 2, but we've just got to tell the calculator that it's f1 that the function is we're working with. So we'll do f1, and notice when you put in the 1, the font changes. That means that the calculator recognizes the function that you're talking about. We'll start our parenthesis, and then we'll put in 2. So we've got f1 of 2 on our calculator page. Hitting enter, the calculator automatically plugs that into our function. So we know then that f2 is just equal to 2. And if you want to confirm that, notice if we had plugged 2 in here, 2 cubed is 8, 8 times 3 is 24. 2 squared is 4, times negative 5 would give you negative 20, and then minus 2. So this is 24 minus 22, which would, in fact, give us 2. Okay? And that's what the calculator is doing. It's automatically plugging that value of 2 into our function. So we can do some other ones. If we want to do f of negative 3, we would just do f1 of negative 3. Again, notice when you do the f1, it changes font, recognizing the function. And it tells us that's a negative 128. Next one we're going to do f of negative 2/5. So we'll do our f1. Now for fractions, the fraction button, which I suggest using anytime you want to put a fraction in, is above the division sign. So we'll do Control, division, and then we'll put in our negative 2, negative 2/5. Okay, and it gives us our answer back. We've got negative 374 over 125. Now, the particular directions for this one said to the nearest, or to 3 decimal places, so to the nearest thousandth. So for that one we had 2. This one we had negative 128. Currently, we have it as a fraction. If you want to switch this to a decimal, go up and select it by hitting your up arrow, hit enter to bring it down, and then if you want it as a decimal, notice above enter is the squiggly lines, meaning approximately. So we'll hit Control, enter, to have it as a decimal. So to the nearest thousandth, or to 3 decimal places, we've got minus 2.992. For the last one, we're going to do 4th root of 12. So we'll do our F1 again. Now, square roots are above the x squared. Any other root is above the caret button right next to the x squared. You'll see it says the nth root. So we're going to do control and the caret button, and it gives us a template where we can put in any root that we want. So we're going to put the 4 in that spot for the root. Then we'll move over. We wanted the 4th root of 12. And again, we wanted the 3 decimal places. So the 7 will round the 1 up to a 2. So we'll have 0.022. Or actually, sorry, the direction said 5 decimal places. So 5 decimal places. We've got a 0 in our 6th place. So the 0 will keep it at 5, so 0.02175. Okay, and that's just a tool that will help you throughout the year. If you have multiple things that you have to evaluate in a given function, put the function in on a calculator page or on a graphs page, add a calculator page, and then you just need to make sure that if you're in F1, that you do F1 of that function, F2 if it's in F2. And the reason I say to open a new document, then you're guaranteed that it's going to be F1. If you keep an existing document, you would just have to recognize what function you're actually plugging it in for. All right, next we're going to work on the calculator working with the table feature. So we're going to create a table of values with a domain of 1 to 4, including the 1 and 4, and we want our table at increments of 0.5. Your table is defaulted to go by ones. So basically we're going to practice here how you could adjust your table step so that you could see different increments in case you need to do that throughout the year. Take a second, pause the video, and put this function that we have here for y in a graphs page. So when you put it in, hopefully you use the fraction button that we just talked about before. So we've got 5 So we've got 5 square root, forgot my fraction button, so you got 5 square root of x plus 2 all over x minus 4. And you should have a graph looking something like that. Now, just some interesting things about this graph that we'll talk about eventually. Some reasons why we don't have any functions or any function values less than -2 is because if you did, then you would get a negative under the radical. And we can't have negatives under a radical. You've seen that in previous courses. You first saw it in trig probably. And then we would have an asymptote at +4 because that's what makes the denominator 0. And you should have seen that last year when you graphed rational functions. But our goal in this problem was we wanted to find our table in steps of 0.5 from 1 to 4. So that means we want 1, 0.5, 2, 2.5, 3, 3.5, and 4. Now, you could do like we just did in the last problem and put in a calculator page and do like F1 or F2, whatever function you put it in for, of 1, 1.5, 2, and so forth. But the quicker way is to go to a table. To go to a table on a graphs page, just do Control-T. And notice our default step is 1. Well, when on the table, if you go to Menu, Table, and Edit Table Settings, our table step is currently at 1, and then change that to 0.5. And then we'll tab down and OK. And it's not really showing up, but there's 1, there's 0.5. OK, there's 1.5. If you have your cursor over at 2.5, let's see if I can widen this. There we go. So now we can see it. So you have 0.5, 1, 1.5, and so forth. So we wanted to start at 1. So we had about negative 2.88 or so. And it didn't tell us where it wants us to keep it out to, so we'll keep it out to a few decimal places. Minus 2.8867, and it keeps going. Minus 3.7416, and it keeps going. We've got a negative 5. Negative 7.0710 keeps going. Negative 11.1803, and it keeps going. And negative 23.4520 keeps going. And then 4, as we had talked about, 4 is what made the denominator 0, so that's why we had undefined. So the whole purpose of that problem is just to have you understand how you can change the step for your x values in the table. Because we'll have instances this year where we might want to look at it every 0.1, every 0.01. Where you would want to change your table step. Next up, we're just going to look at finding roots in our calculator on a graphs page. Roots are the zeros where it crosses the x-axis. Now, in our function, we have a cosine. And when you're working with trig functions, so sines, cosines, tangents, secant, cosecant, cotangent, we have to determine if we're going to be in degrees or radians. For this year, unless it tells you specifically you're going to be in radians the whole year. So we're going to set our calculator to radians. When we are doing that, there's 2 spots we have to check and make sure it is in radians. 1, if you go to home, 5, and then 2, you need to check that your angle setting is in radians. If it's not, switch it to radians, and then when you go down, make sure you go to Make Default. Don't go to OK. That'll just switch it for the current page. Make Default, we'll leave it as that. And then when you get the prompt, just click OK. The other place you would want to go is on your graphs page where we're going to put this. We are going to have to hit Menu and number 9, Settings. And you want to make sure that your graphing angle is in radians. While we're here, another thing we have is our display digits for any values on our graphs page. Now, this question wanted us to go to 4 decimal places, so it might be helpful to just change it right now while we're here to something more than 3. Let's say we may put it at 6. The float 3 will cut it off at 4 digits, whether they be decimals or non-decimals. Float 6 will now allow us to have a little bit more so we can get our correct rounding. And we'll go down and we'll Make Default and hit OK. So now we can put our function in. We had x minus 2 squared minus 3 cos x. Okay, and keep in mind again, this is in radians. And we got a function that looks like this. So our goal is to find where it crosses the x-axis, and we want it to 4 decimal places. So we're going to go to Menu, Analyze Graph. Okay, and Menu Analyze Graph we'll use a lot this year because it allows us to find minimums, maximums, intersections. And in this case, we're going to find our zeros where it crosses the x-axis. We need a left bound. So you want to select to the left of where the root is. So we're going to find the one between 0 and 1 first. So select left of that. The upper bound, select to the right of it. And then your 0 should pop up. So to 4 decimal places for that first 0, we have 0.3096. And then we can do the other thing, or same thing for the other root. So we've got menu, analyze graph, 0, pick your left, pick your right, and we now have 1.4808. Now, you can, if your points end up on top of each other, you can move your cursor over to it until you see the hand, hold down until it pinches the point, and you can drag it away. So we have 1.4808. While we're here, okay, because this question did say with an appropriate window, just to show you how you could change your window if you wanted, say we wanted to go from like positive 10 to negative 10. If you just double-click the values, you can delete them out and switch to what you want to see. And then we could go down here, and we could switch that to negative 10. Okay, and now we could sketch our graph. Notice we have some key things. We know where our roots are now. And notice we also have a y-intercept at 1, so that would be a key thing to draw as well. When you sketch a graph from your calculator, you should put on your axis what your window is. So we went from negative 10 to 10 for all of it. We know we had roots at about 0.3, and we had 1.4, and we said our y-intercept was at 1. So our graph kind of looked like this, and then it kind of went off. Okay, so look for maxes, mins, roots, intercepts when you're sketching a graph. Now, speaking of maxes and mins, the different types of maxes and mins we'll see this year are absolute and then local. And we'll sometimes also call local relative maxes and mins. So an absolute max is something that is the highest value anywhere on the graph. Now notice we got the yellow star here, so this is something you would definitely want to have written down. Okay? The yellow star, remember, means important things that should definitely be written down. Absolute min, likewise, the lowest point on the graph. A local max and local min, which we'll sometimes refer to as relative maxes and mins, deals with a value that is higher, or lower if it's a min, than all of the points nearby. So notice in the local max, that point that I have drawn there, it's higher than all of the points close to it. And over on the local min, that min is lower than all of the points close to it. Now this local min picture also happens to have a local max right there as well. Okay, so that would be a local max. So absolute is for the entire graph. Local is just within that area of the graph. We'll also refer to these sometimes as turning points of the graph. So we're going to practice on the calculator now, finding local maxes and local mins. In this case, we're going to find a local max, and we want it to be between 1 and 3 on our x-axis. So take a second to pause the video and put this function in your graphs page. Okay, so we are trying to find the local max between 1 and 3. Okay, so between 1 and 3, we can clearly see there's a local max. There's other parts of graph up above. So we're going to go back to Menu, Analyze Graph, Maximum. And just like before, we got to select the lower bound, and we've got to select the upper bound to find what that maximum is. Now, if you notice, I think I selected too far to the left and too far to the right, and I got the graph above. So if I do Menu, Analyze Graph, Maximum, I'll do it again and make sure I'm selecting where this actual part of the graph is so that it doesn't catch the graph that's above, because those y values are actually higher than the other ones. So if I said, where does the local maximum occur, we would give an x value. We would give 2.12702. If I asked, what is that maximum value, then that means the y value, so 2.06351. So menu, analyze, graph, maximum can help you find a maximum on the calculator. Now, you can also solve systems of equations on the calculator. Solving a system of equation means knowing the points where they intersect. So you can pause the video, take a second, and plug these two equations in on a graphs page. Now, a couple things. If you do not know how to get the graphing line back up for the function, if you hit Tab, that's what brings it back up to put the second function in. We want to find where this intersects. We'll notice we see one intersection, but it probably intersects somewhere higher as well. So we'll want to change our values on our axis. So maybe let's try 20 and see if we can see it. And it looks like we can see both of them now. So we would do menu, analyze graph, intersection this time. And just like before, you got to pick left of where it intersects and right of where it intersects. And then it'll give you the point. Oops, and I just adjusted my graph. Hold on a second. If you ever somehow change your graph, the calculator is just like Microsoft Word. You can do Control-Z to undo. So when I moved the graph there, I just hit Control-Z, and it undid the changing of the graph that I did. So to find our other one now, we'll go back to Menu, Analyze Graph, Intersection. We'll select the lower bound left of it, upper bound right of it. I'm not sure why the graph is doing that. But so we've got our lower bound, we've got our upper bound, and we get our intersection there. And notice again, when I touch the graph, it moved the graph. If you just do Control-Z, it'll switch back to what it was. So we've got 0.55 roughly and 5.44 roughly for our x values, 2.10, 11.89 roughly for our y value. Now, which variables you need in your answer is dependent on the question. Notice here we have y's and x's, so both your x's and y's, the points, would be your answers. Okay, last thing, if you want to solve an equation on the calculator, there's two ways you can do it. One way, say we had this x cubed equals 5x minus 2. We can do what we just did, graph them separately. In F1, graph x cubed. In F2, graph 5x minus 2. And we can find the intersections. Now, in this case, our original did not have any y's in it. So when you find the intersection, the x is your answer, not the y. In method 2, we could move everything to one side and have the x cubed minus 5x plus 2 is our function. Well, now, on the other side, if we had moved everything over, the other side would really be 0. So we would want to look for the zeros. So just like we did before, we do a menu, analyze, graph, zeros. Again, we don't have any y's in our function, so therefore our x's are our answers. So your calculator is going to give you an x and a y, so it's important for you to identify what is your actual answer. So that's two different other ways that you can use your intersection feature on the calculator or finding zeros. That's all for the video today. We'll see you tomorrow in class.